Hello everyone and welcome back to this video on model size calculation. So this is going to be a short one. We will see how we can calculate how much memory we need in order to load our LLM, and how does choosing the data type completely changes the number of gigabytes we need. So for this, we will assume that we are working with different LLMs in these sizes, so 1 billion parameters, 7 billion, 13, and 70. And we will define our data types. So this is the data type and the number of bytes it takes to store a single element. So basically you divide the number here by 8 because a byte contains 8 bits. So yeah, we have these definitions, and then we have a method that calculates the memory needed for the model. So basically you multiply the number of parameters by a billion. For example, if the input is 1, it's going to be 1 billion. And then you multiply this by the total number of bytes we need per parameter. And then you divide this by 1024 to the power of 3, because you divide once to convert it to kilobytes, then another one to megabytes, and then third one to gigabytes. So now we have a method that calculates the total memory we need for an LLM, and now we're gonna do this in a loop. So we're basically calculating all the combinations, so all the model sizes with all the data types, and yeah, this is what we get. So you can see FP32 is the heaviest one. So this is the data type that uses the most amount of bits, so it makes sense that this number is going to be larger than everything else. And yeah, you can see that for a 7 billion parameter you need 26 gigabytes of VRAM, which is actually huge, and a 13 billion model needs 48. So the smallest A100 GPU is actually 40 gigabytes, so which is a very expensive GPU. So even that cannot fit a 13 billion parameter in full precision. Yeah, so you would need probably an A100 that is 80 gigabytes. I think there are two versions of it, but it's impressive that even one of the most expensive GPUs out there cannot even fit a 13 billion parameter on a single GPU, I mean. And yeah, 70 billion, that's a very huge number, 260 gigabytes. So if you use FP16 or BF16, so again, we are cutting in the memory requirement by half. So it's going to be the same memory needed in both cases. And there are other types like INT8 and INT4. These are even lower in memory requirement. So here we are using only 8 bits, and here we are using only 4. So these are very popular in quantization. So we will be showing in future lessons how to apply QLoRA, which is a quantization technique, and you'll see that this technique actually makes use of these data types, the INT8 and the INT4, and you'll see that it even reduces the memory requirements by half compared to FP16, and by 4 times compared to FP32. And a good rule of thumb that you want to memorize is that for every 1 billion parameter in the INT8 data type, it approximately takes 1 gigabyte of RAM. So 1 billion is just 1 gigabyte. Of course, this is an approximation, but it's a very good rule of thumb. So yeah, that's it for this video. I hope you found that useful, and I'll see you in the next lesson.